Hola, buenos días. Estamos nuevamente aquí en la JConf Perú 2022. Seguimos con las distintas charlas que vamos teniendo. A continuación vamos a estar con Dmitry Alexandrov. Él es un software developer en Oracle, Java Champion, Oracle Groundbreaker. Actualmente está trabajando en el proyecto Helidon. Tiene más de 10 años de experiencia trabajando principalmente en aplicaciones empresariales de Java, en banca, telecomunicaciones. Interesado también en los lenguajes dinámicos de la JVM y las features como la computación masiva en los GPUs. Es un fiel creyente del open source y las iniciativas lideradas por comunidad. Él es el co-líder de la Java User Group de Bulgaria, es el coorganizador de la J-Prime Conference. Dmitry es también un blogger, es un frecuente speaker en eventos locales, así en conferencias como Java One, Code One, DevOps, Boxed, Joker, JPond, y hoy día se encuentra con nosotros aquí en JConf. So, Dmitry, I will let you start the talk, and welcome.
Yes, hello. So great pleasure. Sorry, I don't speak Spanish yet. So it's a great pleasure to be here. It's really amazing that we're able to talk because, able to give you this presentation because you are on the other hemisphere. It's already like getting dark here. It's winter here, and I'm calling you from Sofia. But still, we are able to communicate, and I'm able to give this presentation. So, this is a magic for me, and really great honor and pleasure to talk to you. Today I'm going to talk to you about. I'll take you to a journey, I would say. So a journey from reactive to blocking, from blocking to reactive and blocking back, and I will do this based on this project I'm working on, Project Helidon. So since I'm working for a company called Oracle, so I really have to show you this slide. That means that everything you take as a decision based on this presentation, you have to review it. Maybe something has changed, and maybe there are some changes in policies and businesses, etc., etc. So please check once again before you get to do something with what I'm going to show you today. So, and yes, as I was presented. So my name is Dmitry. I work for Oracle, so you can contact me using those emails. And I'm still mainly on Twitter, but I still also have a Mastodon account as well because it's getting modern now. So you can write me in all social networks you find useful. And as I say, I'm calling you from Sofia. That's Bulgaria. That's East European country. So we are 7 time zones far away from each other. So once again, it's winter here. It's evening, and but still, from our community to your community, we are sending you many greetings, and yes. So hopefully, some of you may take a journey too. Yes, once again, I'm part of some conferences here. So if you join J Prime someday, it will be really, really cool. So let's actually jump into the task of today. So I'm going to define a task and see how we can do it. So yes, the world has shown that we are living in microservices world. That means that microservice as a paradigm, as an architecture paradigm, in a way of doing stuff, has gained a lot of popularity and solves some problems in a really good way. That means that yes, of course, definitely some monoliths you can use, but most commonly, if you want to scale, if you want to make big architectures, microservices is the way to do it. And yes, the most common task that maybe you and I have in our careers is to create a microservice. And how would you do this? I'm pretty sure that most of you will just use Spring Boot because yes, it's cool, it's awesome, it's nice. By the way, we have release of 3 came right this day, so yes, that's definitely an option. There's one small thing that actually makes it a little bit not a good choice. Well, it's not a standard way of doing stuff. That means that whenever something changes, well, you are not the community to control. So it means that whenever you change, you just have to adopt changes, and that's probably it. But actually, still, we need to create microservices, and we need to create it in standard way. That's why came this initiative called MicroProfile. And what is it? So it's an open source community specification exactly for creating microservices based on Java languages. And why is it good? Because actually, it's a initiative which is like non-profit initiative currently hosted at Eclipse Foundation. It's like it's not only one player in it. There are many participants in it. That means that there's not only Oracle, for example. There's also IBM, Red Hat, Payara, Tribe, and even Microsoft is there as well. So Microsoft makes really tremendous efforts to get into Java community now, and they're doing pretty well. So there's a big, communication between Microsoft and Java world right now. So they are participants. That means that all of those guys actually sit together and talk about what the microservices should be and how they should work together. And that's why they create especially this specifications. Specification means it's not implementation. It's just some APIs and descriptions and specifications and some TCKs that other vendors, when they create their product, have to fulfill. That means that what is the good stuff about it? Whenever you write something with one vendor platform, you can easily migrate this code to another platform without any issues in terms of the specifications. And it's released quite frequently, like 4 releases per year. And you can find more information in MicroProfile.io. So once again, you start writing code which is portable in terms of different vendors. So you write your microservice and it can run on some platforms. So, for example, created with Oracle, other platforms created by Red Hat, maybe some run on Payara, Tribe, and it's very easy to interchange the code. So that means that you don't have to rewrite something in terms you need to migrate from one platform to another. And as you see in the foundation, we have like 13 specifications, and they are specially designed to work in microservices environment. And so once again, they're not implementations; these are just specifications that other vendors have to fulfill to make it work. And it's tracing for whenever you have several microservices, they execute one business request. You have to check metrics if until get the telemetry information. If you could check if the service is working or not, because microservices are exactly by computer science an example of distributed computer system, so it can fail immediately, and you cannot control this. So we have to take health checks, and even the configuration is portable. So that means that not only Java code itself, even the configs are portable. And yes, these 13 specifications are part of this MicroProfile initiative. But this is nice. I mean, you start writing portable code, the specifications are evolving, they're nice, good. But have we ever thought about performance here? So mainly not in this way. So not in a fundamental way, I would say. And this is actually what we're going to rethink a little bit in this presentation. So I will take you to a journey from from blocking code to reactive code and back. And I will do this on the project actually I'm working on, so I'm quite happy about it, because Helidon is really a good example in exactly what's because it covers actually both areas, portable microprofile code, not so portable, but reactive and fast code, and all of that is currently based on Meti, and I will give you some interesting news that we have with the release right now. So once again, this is an architecture overview of Helidon. That means that underneath you have Meti, which is a web framework, which is extremely efficient, I would say, because it's asynchronous, it's very fast, very efficient, and actually it's foundation for a lot of other frameworks as well. And on top of it, we have created a layer called Helidon Reactive, actually to fulfill those specifications I was talking about. Not only to establish communication, but also care for metrics, also care for tracing, also care for configuration, also care for I would say working with JSON, because most of the time microservices currently work with JSON format to marshal it, etc., etc. So yes, and that purely reactive. Reactive exactly in terms of the code is asynchronous, it has back pressure, and you start thinking most of the time in a synchronous way. So there is a wonderful presentation about what reactive is by Venkat Subramaniam. So he's an amazing guru. Just Google reactive and Venkat, and you will see wonderful talks that he gave about it. So I'm not going to dig into it a little too much because we are like short of time, and I would take more information as much as possible. And on top of it, we actually build a layer which is compatible with MicroProfile. So that's why we call it Helidon MP. And that means that he uses all the layers underneath, like talk directly to layer only underneath, not through it, not jump over it, with the main idea that you are now compatible with the specification. That means that your code that you write is now portable. It's portable, that you can easily migrate to Helidon, which is the best option, of course. Or you can, if you want to switch to another framework, you just take your code, drop it there, and it will work. So this is what makes MicroProfile so cool. And actually, what is interesting about Helidon that technically, when you have Helidon, you have two products following two different paradigms. As you see, Helidon MP on your right is actually following this declarative style, which is exactly proposed by MicroProfile. So it fairly not copies, but is highly inspired by Spring Boot, which is good because currently the market itself. You find more people working with Spring Boot and thinking in annotations than in pure Java, I would say. That means that you can easily find workforce to do the code you want, and a lot of magic happens there. So you simply annotate your code with quite fairly a well-known annotation, so let's start working. On the left, you will see otherwise the Helidon SE, which is the reactive way of doing stuff. That means that here you have really purest Java. And purest Java, that means that you have only one annotation that you have to do. It is overwrite, actually. And that's cool. And then the code itself becomes not fast, but really extremely fast because it's non-blocking, it's reactive. It has really tiny footprints, and once again, it's pure Java, so you have full control of the code you have. Let's actually jump a little bit in Helidon MP and see what actually do we have here. So as you say, with the Helidon MP, you get slightly more than just implementation of MicroProfile. So we implement MicroProfile and some other specifications as well. They are from Jakarta EE world. So once again, MicroProfile and Jakarta EE are not the same. So they follow different goals. MicroProfile follows the idea of microservices. That means that all the specifications there are specific to microservices world. As in case of Jakarta, this is not so. They're monoliths. Of course, there's intersection between those specifications. They're applicable to both of the worlds, but once again, they're not the same. So, and here you can see that we have more than just MicroProfile, so some Jakarta stuff as well, and some specifications, implementation, which are standalone. That means that they're not part of this 13 specification session, but they're still under developing a community under this MicroProfile umbrella. And as a result, you can see that whenever you create a small application with Helidon, most of the time you have really tiny footprints of memory, really awesome startup times, and very low disk usage. You can see 3 graphs here. So once again, that makes Helidon quite unique because from the very beginning, we are following the idea of modularity, which was introduced back in Java 9. So all the code is modular. That means that whenever you create something like in like write your code, like the framework itself is modular. That means that you can create your custom JVM with Helidon application, which just throws away all the stuff you don't need, and that's why you have lower disk space usage, much faster startup compared to just usual JVM. Well, if you use just the standard way JVM, and it's really working, as you see. And the third option is to use GraalVM, and this GraalVM is it builds you an image with your GraalVM native image, not the JVM actually. It's a GraalVM native image technology, so it just builds you an executable out of your file of your and it has really small standard startup times, tiny memory through disk space usage, but you are having some limitations in the code that you write, and you have limitations in well, in the optimizations, I would say, because once again, if you optimize, JVM constantly optimizes your code for faster startup. If you need it, just use it. But if you need a long distance running code, that most probably it's better to get to real JVM. But what is good about Helidon that we have best-in-class support for GraalVM. So we have full CDI support, well, implemented with well, even in GraalVM, unlike other competitors. So that means that you can compile your applications with CDI, with content dependency injection specification implementation directly to GraalVM. It will work. So that makes us quite unique. And this is also our extension mechanism. Like other frameworks have their own extension mechanisms, like, I'm not too much into details, but here you can have standard CDI models and you can drop them in and it will work. So for example, if we were playing with Neo4j integration, we took a CDI model written for OpenLiberty, for example, we dropped it in Helidon and it worked because it's standard. Yep, that's the power of standards actually. So, and now as we are fully Jakartified, so that makes us vary with Helidon 3 actually that happened earlier this year. We're fully Jakartified, so we're working in the most modern namespace, which is Jakarta. So if you want to start, there's a little bit product positioning, I would say. So we in this so we have this wonderful project starter. So it's also introduced this year, and you can create it with easily created from website, or you can use our famous CLI application. So we can create your project with CLI. So you just go to the website and install it from there. It's compiled for 3 platforms. What is cool about it is it is built with Java and created exactly as a native image. 3 executables are native image implemented compiled executables. So we can use. Let's play a little bit with the demo. How would you do this in Helidon? So we could just go to Helidon.io website. Here we go, just project starter. So, and unlike other starters, when you have to, here's an application, pick all the frameworks that not the frameworks, the modules that you have. We have created it more like a wizard. So you just create the flavor. You want to create a custom project, you can just jump into custom, select what media you need, what security you need, do you need fault tolerance, packaging, do you need to generate a Kubernetes file, observability, health metrics. You want to work with database, what is the database you want to work? And here with next, you create your project. If we just go to quick start, I'm going to demonstrate. It's extremely easy because you just check what are the project group IDs and project names that you have. You simply download it. Then you just unzip it. Unzip my project. Yep, it's downloaded, and then you open it with your favorite IDE. In my case is IntelliJ IDEA. So we will simply need some time. Let me just open it here. Actually, this is the right window. And you can see that it generated some project for us. It's quite easy. I mean, you just have a application scope greeting. You see that you start seeing that the code is very similar to what you have seen in this Spring Boot or MicroProfile way of doing stuff. You have a resource. So here, for example, we say that for a greet on this path, if you call it the default one, you will get the default message like hello world. You can, even with some annotations, document your code as well. So it's really straightforward. And let us actually play with it. By the way, you can just do Maven, Maven package, and it will work for you. But here I will show you how you can do our using it our application in dev mode. That means that whenever it controls, node controls observes your code, and if there's some changes in it, it'll automatically find it and see and apply the changes. So now if we do curl, it will just say hello world, like to us. From default, what is good that you have health checks, for example. So that means that we are cloud native ready. So that means that you see the status is up and running. So all of that you have out of the box. You can even read the metrics, like for example, metrics. So it will give you the metrics in Prometheus format. So quite big stuff you get directly out of the box, even from the generated one. By the way, if we change some files, like for example, here we say, not here, but here, MicroProfile config, and we say, hold on, I guess I'm right here. So you see it detected the changes. And now if we reloaded everything, and now if we do curl with greet, it will say like, it will automatically apply this to us. So it's the same doable with code, with the Maven. So underneath you have Maven. So that's why it's extremely easy, I would say. Nice. So if we go back and jump to where are my slides? Wait a second. So just, yeah, it's here. So I will close it. And once again, the main idea of that is that it's fine, but it's blocking. What does that mean, blocking? That means that whenever you write your code in a blocking fashion, that means that it's like something with, for example, my generation who learned in school, you write it like a recipe. So one operation, then wait for another operation, then wait for another operation to come, etc., etc. So that means that whenever you, for example, want to read something from your disk, from your memory, it will stop, read it, block the thread, and wait for the results and give it to you. So in a fundamental way, it's nice to write just few annotations, but as a performance, it was really hard because it's blocking. So now, to help this, actually, we'll go back to our reactive stuff. And here we come to what is called Helidon SE, as I told you. We call it the danger zone. That means that you have extreme performance with pure Java, actually implementing the same things as you saw in MicroProfile, but not importable in a reactive way. And as you see, when you just throw away all the magic that you have from following the standards, your footprint, disk space usage, everything goes really small. That means that you write pure Java, and you simply don't care about the magic happening. And that's why we call it, it's achieved with reactive way, as we call it in reactive way. And for this, we have created our own reactive engine. So that means that we don't use any other products like Project Reactor or whatever it is, other competitors, which are also awesome, but we decided not to have external dependencies, just to create our own reactive engine, and it's what is good about it is that it's based fully on the Flow API, which is introduced in Java 10, as I remember. And the idea is that we have interfaces like a subscriber, subscription, publisher, which are directly given to you by the JDK, and you just have to implement them. And that means that the engine is pure Java-based, and the main constructions are done with multi and single. So if you think in Spring way, multi is like flux, and single is a mono. So it's the same result. So if you have, for example, multi of some string of numbers, you just give the reactive operators and behind it, and you receive the result. If you have only one value here, and you still can apply on a one value the reactive operators, and that's all done in a synchronous way. So this means that we parse it, we map it, for example, and when it's done, we print it. So it's asynchronous. That's why we are utilizing the resources as much as possible. And for this, we have quite a good set of reactive operators. Maybe the list is not that big as by Project Reactive, but once again, the main idea here is to provide you an, I would say, list which is enough, not all the variety of operators. So, and as a result, you can write your code in a reactive way. So that means that you can do chains of operations. Like, for example, you have a publisher stage. When you just create some stream of values, you can process this stream with some mapping operators, and then a publisher's final stage, you just, for example, print it, compose it somehow and print it. So that means that it's fully functional reactive operator. And what is good about it is that if you compare it to other frameworks, we are sometimes twice as fast as the other frameworks. That means that this operator, this reactive engine is really cool. By the way, just to let you know that it's actually contributed by David Carnap himself, who is actually the father of reactive paradigm itself. So it's contributed by really people who really understand what is it. So, and as a result, so when you have this reactive engine, we have created our own reactive web server. And as you probably see from this code, it's really, really small, tiny. You just will create a web service, so just following a blocking, not blocking, but builder pattern. You just create it whenever started. If you see it will return you a single, so I will jump into the code. And the server was fully in a synchronous reactive way. This gives you really cool performance. Actually, let's jump once again into the code. Yep. So I will now create this application using Helidon CLI. It's just not only for building, but you just can init it. And this time we will use Helidon init SE. And yeah, here's the application. Just answer a few questions and open it in our favorite IDE. Not developed right now. Idea, quick start, SE. Yep. So here is the code. And this code looks, it does the same. What is the funny thing is, it does absolutely the same as we have done with MicroProfile. But you see, the code is just pure Java, and it's a reactive Java. So we create a web server, we build it. It creates a single. That means that it's a value that will, like, promise be returned to us whenever it's initialized. And then you see, when the server is up and running, then accept, like a completable future, that whenever it's ready, just print it's ready. Whenever something goes wrong, because you know the exception flow of stuff happening, Reactive has data flow, control flow, and exception flow. So we have 3 flows. Whenever something goes wrong, you can gracefully handle the exception, and we gracefully handle it. We like exceptionally accept something, like, and we print the stack trace. And the only thing we need is actually to register a service, like a greeting service that we use. And this greeting service is extremely simple because it has, well, the interface has only one thing to overwrite with the update method. When we assign for each path, we assign a handler for it. And as you probably see, that's the only annotation that we have here. Override, no other annotation, no magic at all. And here, for example, we have a server request, a server response, and we just say, like, for example, hello world. Once again, I'm not going to dive too much into details because we're short of time. But the idea is that now you work the same way, you have the same stuff, but now it happens completely reactively. Reactively means that it works asynchronously, saving us a lot of resources and well, doing the stuff much more effective. So what is good about it is, since it's just a main, I can just run it directly from the IDE. So you see, it simply starts like this. And now we can work and do the same curls like greet, and you have absolutely the same result, like health, but now it is done in a synchronous way. So even more information is given here. So like I have a lot of free space still on my machine, and this makes it quite unique. So the metrics are the same. So just give you absolutely the same, but in a reactive way. You could, as I told you, you can simply start it, and by the way, debug it here from the IDE. As easy as that. So you can just try it. So my idea was here not to dive into details, but like there is another way of doing stuff, another product, and it's just doing the stuff reactively. Good. Oops, not this one, not share, but slideshow. So you can do MicroProfile messaging. That means that all the messaging that you have following the MicroProfile messaging model, you do it reactive in a native way, I would say. So you have not a wrapper, but like a common interface abstraction over them. So you send a message, then you have an implementation, should be Kafka, QnJMS. You have connectors to those databases, not databases, messaging brokers. And it works. So it's based on the MicroProfile way, but you do it in a reactive way, following our reactive engine models. So it's really, really good. The only thing that you have, like, not a problem, but the small issue with the paradigm, that once reactive, you always have to do reactive. That means that if you have to do to work with database, and database is synchronous, you can't synchronously work with database. So that's why we created our own DBClient, which actually runs your database in a separate executor, allowing you to work with it in an asynchronous way. So this means that now, if you want to have a microservice that wants to connect to database, so it will do this asynchronously and reactively from the very beginning. The same as if you want to read some other services, like if you want to be a client for other services, you simply don't have to block until the result comes to the network. So that's why the service itself is also asynchronous. Once again, that's cool, but the practice show it's a little bit trap, as I say. So that means that reactive programming really solves you quite a lot of issues, mainly for the performance. But the paradigm is hard. It is hard to learn. It is hard to troubleshoot. It's hard to debug. And even writing code for reactive is hard. So that means that, you see, there was a blocking way which was not performant. There is a reactive way which allows you big performance, but creating this code is considered by the community, not only me, but like hard. And I don't know many people who actually can do reactive programming. So it is, I would consider it as hard. But what is it too hard? What we do? So we have a choice, either to make portable, nice portable blocking codes, which gives us some performance issues which are fundamental because it's blocking, or we have to write a reactive code which is not portable. It is hard to debug, but it's extremely performant. So actually, that's why Helidon has established like a double phase project. Like, you know, you have a paradigm of blocking and you have performant paradigm of reactive. But was it too hard? So what can you do? And here actually comes the big salvation, which is called Project Loom, which was released actually this year. So it was previously one of the research projects for several years. And now they say, okay, we can introduce those virtual threads, which are very, very I would say, very, very cheap resource threads. And it will help a lot exactly in terms of performance and reusing those resources that we have. Let's say, what's the main problem of blocking code? That it blocks your thread. And Java from the very beginning has works with threads in terms of it's a wrapper of an operating system threads. That means that thread is an expensive resource. That means that, okay, your processor can handle like, well, in this case, it can handle 10 threads. Many processor can handle like, you know, 64, maybe 128 threads, etc., etc. But here we have as an expensive resource. And if you block the thread, the CPU simply don't work. So what they did, so they have introduced something called virtual threads, which are mounted over real threads. They call them carrier threads. Virtual threads are actually the same as an API of a, you won't see difference in the API between normal thread and virtual thread. But the JVM cares for them to be, whenever they're blocked, it will unload them, like, you know, from the carrier thread, unmount them, and this free resource, give this free resource to something else. When the scheduler understands that this thread is unblocked, it will, you know, try to give this to other threads. So that means that we are starting to care more for the free resources that we have, and we have starting to optimizing them as much as possible. So currently there's no need to go to early access build because it is already available with you with JDK 19 as a preview feature. So it only allows us uses additional APIs like virtual thread executor. And what is cool about Helidon is that even from the research phase of the project, we already support them. That means you only to add one option, like, you know, one parameter to the configuration, just to enable them, and it will work. That's it, as easy as that. Actually, I will show it to you a little bit later in the comparison. So virtual threads are a way to create a well, like, you know, blocking application, a non-blocking application with blocking paradigm. That means that you don't have to like, you know, rewrite your code to virtual to achieve peak performance. And for the enterprise, this is like, you know, amazing. You simply change one option and it starts performing. So once again, it's really cool, but it's like putting an electric engine on a petrol car. So you can do this, but we decided that we need to create, because once again, we're based on Netty, and we simply give Netty a virtual thread pool executor there, and it works. But we decided, okay, Netty is asynchronous by its nature, and are doing blocking code. So we're blocking on asynchronous environment. And we decided, okay, let's just throw away all the asynchronous stuff and create a fully blocking web server. And we did it, and it's called Nima. So it's the world's first framework, which is based on exactly on virtual threads. It's totally blocking. That means the code there is totally like, blocking. There's no reactive in it at all. And with virtual threads, it gives you performance comparable to netting. So that means that if we throw away all this reactive wrapper and netty underneath and just put Nima there, we will achieve a really awesome performance. That means that it's currently work in progress. We're still, doing blocking modules, but the core modules are already ready, and that means that we already can try. What is good about Helidon is this layered architecture. So that means that we can simply, throw away the unblocking stuff and put blocking it into a work. So that means that virtual threads are exactly one of the ways us to start writing blocking code and achieve performance on an unblocking way. So this web server already has big support for HTTP 1.2, gRPC, WebSocket. It has integration framework support, TLS and TLS support is extensible. You can set access log core support, write static comment, and open telemetry, all of these observability features. And what is good that it's completely rewritten from scratch, and it's based on the newest technologies, virtual threads, enhanced switches, sealed classes, good system logger. That means that there's no legacy in it. It's really new. And well, do not jump into this model at all, but why would you actually do this? And that's why. So when you left, you see a code which is asynchronous and blocking, non-blocking, reactive code. Async, create, invoke something, thread slip for single, set, exceptionally do. And on your right code, you will see the equivalent, which is blocking. You can see that there is no reaction. And here we have that the performance itself is even a little bit higher than netting. And what is the best stuff? So we're just in the introduction of Nima. Your every MicroProfile application gets much more performance, as you can see from here. So twice the performance, even times the magnitudes of performance just by switching to virtual threads. And once again, you can put an electric engine on a petrol car, it will work. But here we have created something which is dedicated, especially for like electric car. That means that you just have to throw away from the head all these traditions that you have to create for petrol car and create a completely new architecture for electric car, following the needs that it has. And let us jump to the demo I have prepared for you. So we have several clients and several servers which are going to do, we're going to show you the performance. So we have quick client and slow clients. So first of all, we have quick request and slow response. We have specially limited the thread to 10 threads to show you. And what is the main idea? So as you can see, we have just two endpoints, slow endpoints and quick endpoints. So in the slow endpoint, we simply slip and block the thread. In the quick response, we just give the result. It's extremely simple. And here we have a client that monitors the quick and the slow endpoints. What is the main idea? Whenever we do slow requests, they will block the thread and simply will get out of threads. That means that at some point they will block everything, do nothing, and the quick clients will never ever get the chance to get their response back, so they will just time out. We have the same as a reactive alternative, so it's written in a reactive way. So I've shown you that's simply main method. You see how small it is, and two services which are quick and slow. And we have the same written in Nima, which is like, it's also just a main function. Very, very straightforward. And once again, quick and slow response, as easy as that. But here in Helidon, we have two other options, which are, we just say, use virtual threads or don't use virtual threads. As easy as that. So let's jump into the code. I have wait a second. So I will quit this from here. So I will get out of it. And I have a special view of where is it? Window group for virtual. Yes, that means that. So what we do, we start our server with no loom. So it just starts as a Helidon server. And here we just run our java-jar clients slow. It will start monitoring. And here we just java-jar target clients quick. So what we see here, that's it's serving us slow requests, but the quick client simply does not have performance and it blocks with a lot of errors. If we do see the performance of the code, it's really low performance. It means we sleep a lot and the processor usage is really not that good. So if we do the same but in a reactive way, you see it start querying as much as possible. Target, what is it here? Server reactive. All of a sudden, we see that the blocking requests are blocked, but we still are able to serve the quick requests, 20,000, etc. And you see the processor usage. That means that we are faster and we started like utilizing the resources the best way. Every time there is blocked something, we use it resources while it's sleeping to serve other requests. It's non-blocking performance. Good. And here, so you see, but now if we go to blocking once again and enable Loom, what we will see, it will start blocking the same way. It only needs some time. We will see that all of a sudden, the same blocking code that we had starts responding like a non-blocking application, which is actually the best part of it. So that means that we have unleashed this resource that we had previously. It's simply by switching to virtual threads. And to make the full performance of it, so there is enable preview, because we're using virtual threads here. Targets and server Nima, which is completely blocking. Enable should be this way. Yes, that means that now as it's completely blocking, but we're still able to get a good performance. Like I'm showing to you that we're giving performance in a completely great way. So this is just by enabling virtual threads. So that means that now, if we go back to our presentation, you are still able to do performance. You unleash these resources that you haven't used before, and you only have to know it's not performance boost. It's just reusing the resources which are blocked. Because if you are coming to an idea of abstraction, long-term utilization of a thread, your CPU won't get more performance. But microservices themselves are very nice because they use small amount of time. So the tasks are small, and that's why you can block it for some small time, and it's not going to obstruct your code and not obstruct your processor. So that means that either you use reactive way or blocking with virtual threads, it will do the stuff. There's some challenges here because we simply have no time. The only because I'm at time already. One idea is that now the biggest challenge is to all learn to do reactive and write blocking code, because blocking code performs even better than reactive code. That means that now I've taken the journey back and forth. You can write portable standard blocking code and achieve performance of reactive application. And this is based on this example I've shown you on Helidon. And if you want to play more with Helidon, so just follow those links. There are a lot of them. We are in Twitter mostly, but we are also in Mastodon if you like it. Head Twitter, LinkedIn. We have YouTube channel. If you have questions, just Slack it to us, and that will be extremely awesome. So with this, I want to say big thank you for having me. I'm sorry I'm 5 minutes late, but once again, if you have any questions, I'm here to answer them. And once again, thank you for the opportunity to talk to you.
Thank you, Dmitry. We don't have questions yet, but sure, the topic was really interesting.
I guess we're connecting.
But I have one question, actually. You know, the use of virtual threads is not like you...
Joseph?
Yeah, I have a question. I have a question, actually.
Okay.
There is no one for the audience, but for me.
Yes.
Yeah, it's the difference. So there is no boosting on performance. It's just a new way of using the same resources that we have when we are using blocking code, right?
Yes, exactly. So that means that whenever you block your code, this resource which is blocked can be reused by other resources. And that's why the overall performance is better, because the system does not sleep and does not, like, stay blocked. And if previously it was achieved with reactive code, which is asynchronous by its nature, but it was hard to write and hard to debug, now it is achieved by the JVM caring for these resources for you. So with Project Loom, you write blocking code, and the JVM manages the resources. And whenever the resource is sleeping and doing nothing, or waiting for an IO, for example, it will just give it to another thread. And that's why your CPU gets more percentage of usage. Yeah, that's
awesome.
the idea.
Awesome.
Yes, and that's why. Yeah, and the other thing is that, as you see, it was based on reactive code just to boost performance. And now as we created a blocking code, fully blocking code, from the very beginning, it's still giving us even more performance, just because the JVM manages it. Yeah.
Yeah, I just wanted to add one more question regarding that is just the paradigm. Reactive can be a little bit tricky, actually.
Yes.
But I was going to ask, just in an enterprise ecosystem, mainly you have you probably have been using MicroProfile, so the actual blocking code from there it can be executed on the new environment, no? Like using this by using Nima and this project, or do I have to do some other stuff?
No, that's the idea. If you have portable code, you just run it there and it will perform better. So this is the biggest magic that you receive, actually. That's with Helidon, with Nima underneath, for example. Yes. It will be still the same as I showed you, actually. Where is it? Where is the code? Where is the IntelliJ? So the code itself will be absolutely the same. So you will write the resource this way, with like path, inject, like get, etc., etc. You will do the same code, but it will perform much better, just because underneath the JVM cares for these resources which are not used with virtual threads. Yes.
Awesome.
So this is the coolest part, that you don't have to rewrite anything.
Yeah, I was actually checking that, and also that would be really helpful for enterprise and people that are
Exactly.
working on the projects in the past that just can use this new feature and new implementation of a web server. No?
Exactly.
Well, thank you, Dmitry, for the time. Actually, it has been an amazing talk, and
Thank you so
hope we can have you here maybe in the future. Thank you
Absolutely.
again.
I have been only to one country in South America. I want to make more, and yes, now as the COVID restriction is less, maybe it's a dream for me to come to your country. So I'll be quite honest. So whenever I'm there, I will write you.
Awesome. Thank you, Dmitry. Para la comunidad,
Thank you.
ahora, thank you. Vamos a continuar. Si no se olviden de hacer sus preguntas y que se va a haber un sorteo de licencias IntelliJ, así que por favor nos vemos en las siguientes. Thank you, Dimitri, again. Bye.
Bye bye.